This video is about the relationship between radicals and rational exponents. That relationship is that they're the same thing, essentially. The relationship is shown here. So, for example, b to the 1 divided by nth power, that's the same thing as the nth root of b to the first power. Generally speaking, if we had any kind of radical under, so any index radical, so like a third root, cube root, and the radicand was some power, the way you can convert between the two is like this. Now this statement here, the nth root of b, so the nth root of b to the m is the same thing as the nth root of b all to the mth power. That comes from the same idea as the nth root of a times b is the same thing as the nth root of a times the nth root of b, provided that a and b are both real numbers. In this case, b is itself, so b and b would still be this. B would still be a real number, but the way we can see how this works is if we had the nth root of b times the nth root of b, well, that's the nth root of b like squared, so this would just be the nth root of b squared, which we also know is equal to the nth root of b squared. Because rational exponents are just exponents, all the same rules for exponents apply to these as well. So, for example, we had the quotient rule before. It was that x to the n divided by x to the m is equal to x to the n minus m. Same thing here. Notice, though, there's that extra step where you can't just, you still have to subtract fractions here, right? Rational exponents are fractions, so you still need to do all the things you need to do to subtract fractions, that is, to get a common denominator. So in this case, you'd multiply the 1/4 by, because the LCD of 4 and 6 is 12, so you have to multiply the 1/4 by 3 over 3 and the 1/6 by 2 over 2 to get these products, and then you can subtract. So you get x to the 1 over 12, which can be written as the 12th root of x to the first, as we saw on the previous slide. Okay, the same rules apply here. We can't do anything to simplify what's in the parentheses, so just like when we had x divided by y to the nth power, that's the same thing as x to the n divided by y to the n. Same thing, so 12 and the 1/2, they multiply, right? It's powers, we multiply powers, so 1/2 times 12 is 6, 1/4 times 12 is 3, and then that's it. Since they're different bases, you can't combine them. And how they're related to roots, again, this here, we don't really know how to do this. We can't multiply two different indice roots, so two different indice radicals. So we have a square root of 3 times a cube root of 3. It doesn't make a ton of logical sense, the process for which you can multiply those two together. The key for doing this is rational exponents. So if we just convert the square root of 3 to 3 to the 1/2 power and the cube root of 3 to 3 to the 1/3 power, well then this is just this rule, right? X to the n times x to the m is equal to x to the n plus m. And so now we have 3/6 plus 2/6 after you get a lowest common denominator, which is 3 to the 5/6, and then you can write that in your simplest radical form, which is the 6th root of 243. If you saw this multiplication problem and immediately were able to figure this out, please tell me how. So here's an example where we can't just take the cube root of 4 and multiply it by the square root of 8 directly. This is a very, very complicated process, but the way we do it is through rational exponents. So we can right away, we can convert our cube root of 4. We can say, well, we can't say that's the cube root of 2 squared, and we can't say that that's the square root of 2 cubed. Then we can convert those into rational exponents and say that this is 2 to the 2/3 power times 2 to the 3/2 power, 3/2. Now that's the same thing as 2 to the 2/3 plus 3/2, and all we have to do now is add 2/3 and 3/2. So common denominator between 2 and 3 is 6, so we have, this would be 2, multiply that by 1, multiply that by 1. What we end up with is 2 to the power of 4/6 plus 9/6, which is 2 to the power of 13/6. And so that is the rational exponent version here, but it's not in simplest radical form, because if we were to write this in simplest radical form, we would see that the 6th root of 2 to the 13th is not simplified because this exponent is greater than this radicand. In fact, I can pull out 2 to the 6's in here, right? I can say this is 2 to the 6 times 2 to the 6 times 2 to the first. 6 plus 6 plus 1 is 13. So this ends up being 2 squared times the 6th root of 2, or 4 times the 6th root of 2. Go ahead and see if you can come up with the answer to this problem. The answer is y to the 5/12. Now for a problem like this, it is definitely possible for you to use this property right away, that x divided by y to the nth power is equal to x to the n divided by y to the n. So effectively what you're doing, kind of, is distributing the 3 into every single thing here. However, we're dealing with parentheses, and if possible, if we can ever simplify what's in the parentheses first, we should do that every single time, because it will save you headaches moving forward. So how would you do something like that? Well, the 4 and the 2 just becomes a 2. So let's write a new kind of in parentheses here. The a, this is a squared divided by a to the 1/2, so it's a to the 2 minus 1/2. And then this is x to the 1 and x to the 1/3. So this is going to be x to the 1 minus 1/3. And there's actually nothing on the bottom. So what that lets us do is rewrite this a little bit. If I want to take, 2 minus 1/2 is just 3/2, so it's 2 times a to the 3/2, and then x, 1 minus 1/3 is 2/3, so x to the 2/3. Now that is to the 3rd. Now I can do this property, and that will give me 8, because 2 cubed is 8. A to the 3/2 times 3 is 9/2, my bad. And then x to the 2/3 times 3 is just x squared. Oh, sorry, I didn't put the a there. X squared. So that's the answer. If you wanted to, if you were asked to put this with a simplest radical form, that suggests that you need this radical symbol here. And so the only thing that would go inside of a radical because of this rational exponent is the a. So we have 8x. So we actually have, right, what would this look like? The square root of a to the 9th. You can take out 4 a squareds out of that, right? So this would be a to the 4th times the square root of a. So then it would be 8x, or 8. So you can write this as 8 times x times a to the 4th times the square root of a, or you can kind of switch the location of those two things. We said the squared, sorry. So that is how you would do a problem like that. Okay, so I've shown the answer to this problem here. This is a very difficult version of this kind of problem. And also note that when we talk about rational exponents in the future, we will be in the context of solving for variables using rational exponents. And that's kind of an introduction to something called logarithms. And so we'll talk about these in a lot more depth. Your focus here should be on comfortably switching between rational exponents and radicals for now. On the next slide, I have the solution, so pause the video right at the end, and you can look at the solution to this problem here.